Okay, so we're continuing horizontal asymptotes to help us answer our limit problems, the limit problems that we see infinity in the actual problem. Again, vertical asymptotes, the answers may have something to do with infinity, but horizontal asymptotes have something to do with the problems where we see infinity in it. Okay, so in this particular one, it's a continuation because now I'm going to review how to find horizontal asymptotes of a function the way in which we kind of did it in pre-calculus or maybe in some other math courses. So to find the horizontal asymptotes, number one, if the degree in the numerator is less than the degree in the denominator. So this is only applying to when you have a function where there is a polynomial expression in the numerator and a polynomial expression in the denominator, because those are the ones that have a degree of n, okay? So I adjusted the coefficients and wrote the rest of the expression in the numerator. And let me write a coefficient here as well for n, but that's what I'm trying to describe to you as you go through finding your horizontal asymptotes. So these rules only apply for when you have a rational function. All right, so you do need to know when you have a rational function or not. So in the previous lesson, we had examples, and in example A, even though it was a fraction and we saw it as a rational function, this is not something that we can use because we don't have a polynomial expression in the denominator. But for part B, it was just 1 over x, and that is a rational function where you have a polynomial in the numerator and in the denominator. So this can apply for that, as well as what you're going to see in our example problem today. So hopefully you're copying down part 2 by now, and it's saying if the degree in the numerator is equal to the degree in the denominator, then y equals not 0, but the leading coefficient of the numerator divided by the leading coefficient in the denominator. So that would be these two values, okay, divided. 2 is repeated because this was part of my slides, and I was afraid students would still be copying step 2, so it's just repeated again. And so we're up to step 3. Actually, they're more like rules, and these rules are created by understanding the end behavior model, which is what we'll get to soon enough to understand how to find limits even further. So you'll understand how these rules even developed. So 3, if the degree in the numerator is greater than the degree in the denominator, then there's no horizontal asymptote. So it's really just 1 and 2 that'll help us find it, but 3 will tell us if there isn't one. And again, this is only the rules for these types of functions. Okay, so here's our example problem, and it may look familiar, but we're going to find the horizontal asymptote for f of x and then answer limit problems. So for f of x, we see it's a rational function. There's a polynomial in the numerator and a polynomial in the denominator. So if we do see x, it's x to the first power. If you don't see x, it's x to 0 power. And that was supposed to be a 1. It looks kind of like a 2. If it's x squared or any other number, it's obvious what the degree is. So the degree of the numerator is 1, and turns out the degree of the denominator is 1. So 1 is not less than 1, but they are equal to each other. So there is a horizontal asymptote, and where it is when you divide the leading coefficients. So for this one, it's 2, and for that one, it's 1. You have to know that that's there. So 2 divided by 1 is 2. And so that's how you can find a horizontal asymptote of a rational function. So when we did this the other day and I drew the graph, that's why I was able to put a dotted or dashed line when y was equal to 2. So now, it just so happens that these problems right here that we have to answer are very simple, okay? They equal the horizontal asymptote, which is 2. Okay, so I can do something like that, or I can say that this one is also 2. Either way. All right, so if you can show work to find the horizontal asymptote, then you can get your answer. So this is your problem, this is your work, and there's your answer. Again, this is only for when you have rational functions. Otherwise, you have to approach it in a more graphical way or numerical way. Good luck.